We are a speck in the middle of a cosmic void, occupying what we call Earth. He convinced Voyager to turn its camera back toward Earth, capturing what essentially became Earth's first-ever selfie. That picture was taken, and there was this pale blue sitting in the vast emptiness of space. First of all, we've detected 500 bursts of radio radiation. Most of them are irregular. They burst once in a millisecond and then disappear forever. Voyager 1 has found 500 undiscovered objects in space during the past 5 years. Currently, Voyager 1 is traveling through the interstellar medium, exploring regions inaccessible to terrestrial observatories and uncovering mysteries that continue to astound us. Voyager 1 is the result of countless brilliant minds working together worldwide. Laboratories across the globe have contributed to its success. This spacecraft serves as a message to the uncharted territories of space. It opens our eyes to the incredible treasures of the universe through this engineering marvel. Neil deGrasse Tyson recently verified that Voyager 1 has discovered 500 unidentified objects drifting through space. As soon as scientists began analyzing the data collected, they were astonished. A bizarre formation appeared on the horizon, baffling even the most accomplished scientists. Several theories have been proposed to explain this enigma, but none have provided a definitive answer. Ever since Neil deGrasse Tyson confirmed the discovery, scientists have remained skeptical of any unusual information coming from space. However, we are discussing Voyager, a spacecraft that has outperformed predictions for nearly 50 years. Based on historical findings, Voyager 1 has outlived scientists' expectations, staying operational for almost 45 years in space. What makes this discovery even more fascinating is that Voyager captured it from so far away. When scientists last checked in with the space probe, they found it traveling at a speed of 14.5 billion miles per hour, showing no signs of slowing down. According to calculations, the probe travels an annual distance 3.6 times that of the Sun and Earth combined. While the probe's speed will gradually decrease over time, it continues to push the boundaries of space exploration. Voyager 1 has delivered memorable and thrilling news throughout its mission. Scientists were concerned when reports surfaced about 500 unidentified objects seemingly materializing out of nowhere. As they scrambled to find an explanation, they realize how little we truly know about the universe. One moment, we are unaware of these objects. The next, they exist before us. Some experts initially believed the discovery might have been an error. Given Voyager 1's advanced age, it is possible that incorrect data was transmitted. After all, Voyager 1 has been serving humanity for over 50 years since its launch in 1977. If the spacecraft's computer were to malfunction, it could start sending faulty signals, leading to confusion on the ground. Despite the fascinating nature of this discovery, experts warn against making hasty assumptions. Voyager 1's mission has always been about scientific exploration, and it continues to provide insightful data about our universe. Unlike its twin, Voyager 2, this probe features a dual redundant computer system that contributes to its endurance. The spacecraft relies on two critical subsystems, the flight data system and the attitude and articulation control system. These components allow Voyager to maintain its unwavering spirit of perseverance and exploration. The redundancy in its design enables engineers to switch systems without interruptions and revive dormant computer components if needed. Engineers developed a power management strategy to maximize Voyager 1's efficiency. Since the probe has limited power, scientists had to make tough choices about which systems to prioritize. One strategy involved shutting down non-essential systems to extend its operational life. For example, heaters that maintain equipment temperatures were deactivated to conserve power, despite the risks involved. Balancing power conservation with research goals is not an easy task. Every decision requires careful consideration and teamwork. Scientists must ensure that Voyager 1 continues gathering important data while maximizing its longevity in space. While the spacecraft has exceeded expectations, there are still ways to maintain its viability. As Voyager 1 continues its journey into the vast expanse of interstellar space, it moves farther from the Sun, encountering a dramatic reduction in available solar energy. Unlike spacecraft operating within the inner solar system, which can rely on solar panels to generate power, Voyager 1 depends on its radioisotope thermoelectric generators, RTGs, to sustain its operations. These RTGs convert the heat produced by the radioactive decay of plutonium-238 into electricity, allowing the probe to continue transmitting valuable data back to Earth. However, as the years pass, the power output from the RTGs gradually declines, requiring engineers to make careful adjustments to manage the spacecraft's energy consumption effectively. To compensate for this inevitable decrease in power, mission engineers at NASA have implemented a series of strategic power management measures. They have systematically turned off non-essential instruments and subsystems to extend the operational life of Voyager 1. For instance, heaters that were originally used to keep certain instruments at optimal temperatures have been deactivated to conserve energy. While this means that some instruments operate in colder conditions than they were designed for, careful engineering has ensured that the critical systems remain functional despite the challenges of deep space. By selectively shutting down specific components, engineers have been able to maximize the longevity of Voyager 1 and ensure it continues to relay scientific data from the unexplored regions of the cosmos. Power management technology has also continued to evolve over the decades since Voyager 1's launch in 1977. Modern advancements in energy efficiency and system optimization have provided engineers with new techniques to refine and improve the probe's operational capabilities. While Voyager 1 was built with technology from the 1970s, ongoing research into low-power electronics and energy conservation has helped mission controllers develop creative solutions to keep the spacecraft running. The ability to remotely reprogram Voyager systems, despite the immense distance between the probe and Earth, has been a critical factor in maintaining its functionality. Engineers regularly analyze power distribution and adjust settings to ensure that the spacecraft's most essential functions, such as its scientific instruments and communication systems, remain active for as long as possible. Another key aspect of power management involves optimizing the use of Voyager 1's communication system. Since the spacecraft is now more than 14 billion miles from Earth, transmitting data requires significant energy. Engineers have carefully adjusted the way signals are sent and received to minimize power consumption while maintaining a stable link with NASA's Deep Space Network, DSN. By fine-tuning the spacecraft's transmission methods, they have been able to extend its ability to send back data about the interstellar medium, cosmic radiation, and other deep space phenomena. Despite the challenges posed by decreasing power levels, Voyager 1 continues to push the boundaries of human exploration. Thanks to the ingenuity of NASA's engineers and advancements in power management, the spacecraft remains operational, providing humanity with unprecedented insights into the mysteries of interstellar space. Breakthroughs in battery charging methods, power delivery, and control systems have played a significant role in prolonging the spacecraft's lifespan. Engineers have successfully distributed and managed Voyager 1's energy resources, allowing it to continue deep space exploration without fear of running out of power. Despite its advanced age, Voyager 1's primary engines continue to function, transmitting critical data back to Earth. This incredible achievement is a testament to the dedication and ingenuity of the scientists and engineers behind the mission. Initially designed for a 5-year mission, Voyager 1 has defied all expectations by remaining operational for nearly 5 decades. Even with careful planning, unexpected challenges arise. The discovery of 500 unidentified objects serves as a reminder of the unpredictable nature of space exploration. Scientists were shocked when Voyager 1 transmitted an urgent warning about an unidentified object. For a brief moment, it seemed as if the spacecraft was under threat. The scientific community declared an informal emergency while engineers worked to determine the cause of this anomaly. Typically, Voyager encounters asteroids, space pebbles, and micrometeoroids. However, these newly discovered objects do not match anything previously cataloged. Technically speaking, these unidentified objects appeared instantly, adding an extra layer of mystery to the already puzzling data transmitted by Voyager 1. The sudden and unexplained appearance of these objects in the spacecraft's readings raised numerous questions among scientists and engineers. Given Voyager 1's vast distance from Earth, over 14 billion miles away, any anomaly in its data was a cause for concern, as it could indicate anything from an instrument malfunction to an encounter with an unknown celestial phenomenon. The scientific community was quick to respond, launching an extensive investigation to determine the nature of these mysterious objects and the validity of the data being received. One of the first steps taken by researchers was to assess whether these objects posed an immediate threat to Voyager 1. The spacecraft, despite its age, continues to function remarkably well thanks to decades of careful power management and system adjustments by NASA engineers. If these objects had been physical entities capable of colliding with Voyager 1, the consequences could have been catastrophic. However, initial analyses quickly ruled out any direct danger. There were no sudden fluctuations in the probe's trajectory, no signs of impact, and no disturbances in its communication with Earth. This reassured scientists that the objects, whatever they were, did not pose an immediate risk to the spacecraft's continued operation. Yet, despite ruling out any immediate threat, researchers still faced a significant challenge, explaining why Voyager 1 had detected such unexpected and seemingly anomalous data. The probe's scientific instruments, designed to study the interstellar medium, cosmic radiation, and other deep space phenomena, had never before recorded anything quite like this. If these objects were not physical threats, could they be something else entirely? Some scientists speculated that they could be unusual fluctuations in cosmic rays or plasma waves, while others considered the possibility of an as-yet unknown astrophysical event. The possibility of data corruption or instrument malfunction was also considered, though careful checks of Voyager 1's systems showed no immediate signs of failure. One of the major difficulties in solving this mystery was the extreme distance between Voyager 1 and Earth. Signals from the spacecraft take over 22 hours to reach mission control, meaning that real-time analysis and responses are impossible. Every adjustment, test, or command sent to Voyager 1 requires nearly 2 full days for feedback, significantly slowing down the investigation. Nevertheless, scientists and engineers remain determined to analyze every aspect of the data. By comparing the latest readings with previous transmissions, they work to determine whether the anomaly was a brief glitch, an environmental factor in deep space, or something entirely new. Ultimately, the mystery of these unidentified objects underscored the challenges of deep space exploration. Voyager 1's continued ability to send back data, however perplexing it may be, is a testament to human ingenuity and curiosity. Whether the objects turned out to be a rare cosmic event, an error in measurement, or something else entirely, the incident served as a reminder that even after nearly 5 decades of travel, Voyager 1 is still capable of surprising us. Initially, researchers suspected that the anomaly was a defect in the observation system. However, there was no obvious explanation, and the signal arrived unexpectedly. Voyager 1 continued to transmit enigmatic signals while still responding to mission control commands. The strangest part was that the spacecraft's antenna remained correctly aligned with Earth, ensuring proper communication. Scientists were perplexed. How could Voyager 1 be transmitting such odd readings while still functioning normally? As researchers investigated further, they discovered a connection between the anomaly and the spacecraft's attitude and articulation control system, ACS. The issue stemmed from ACS transmitting data from an onboard computer that had long since been decommissioned. Essentially, data meant for Earth was being intercepted by this outdated computer before transmission. Scientists still needed to determine why this occurred, but they were relieved to have identified the cause of the anomaly. To fix the issue, engineers programmed ACS to convert the intercepted data back into usable information. This solution was considered low risk and ultimately resolved the problem. However, another challenge arose: communication delays. Given that Voyager 1 is currently 14.5 billion miles from Earth, radio signals take about 22 hours to travel one way. This means that mission control must wait nearly a full day for a response to any command. To minimize errors, engineers carefully review instructions before sending them to Voyager 1. Although frustrating, these delays are a natural consequence of deep space exploration. Scientists believe that the anomaly was caused by ACS receiving incorrect directives from the outdated onboard computer. However, other possibilities, such as cosmic rays or micrometeoroid impacts, cannot be ruled out entirely. The universe remains a formidable and unpredictable environment, even for a spacecraft as resilient as Voyager 1. As it continues to explore the farthest reaches of space, we can only wait and hope for its next fascinating discovery.